We will start off again by showing that it runs with no corruption in the network. So loss and corruption are 0. The client is in the bottom right where we care about getting the pig Latin back. So there's the first one, the second one, the third, the fourth, and the fifth. So all 5 come through just fine. Now we can rerun it with corruption in the network. I will set loss to 20% and corruption to 20% and rerun it. While that is running, we can look at the packet class to show that it's modified. So we added a 1-bit integer in between the sequence number and the length, with a 1 for a positive acknowledgement and a 0 for a negative acknowledgement. So here we have an empty message with a 1 for the positive acknowledgement when we're sending an ACK. When we're sending a NACK, it is an empty message with a 0. So let's look back through and make sure we got all the right answers. That one's good. That one's good. That one's good. That one's good. And that is all 5. So all 5 run with corruption in the network. Let me show you that we do not deliver corrupt packets. So let me find corruption on the server. So here we got a corrupt packet when we were trying to receive this C message. So we sent a negative acknowledgement because we do not want to resend corrupt packets. We wait until we get a good one, then we convert it. So that shows we do not deliver corrupt packets. Next up, we need to show we resend data following a negative acknowledgement. So let's find one. Confirmation ACT is 0, a negative acknowledgement, so we resend the message. Retransmit after a timeout. Let me see if I can find one here. So the message we sent got dropped, which is what caused the timeout here. We had no confirmation acknowledgement, thus we sent the message a second time, as we can see by our timeout counter here, which shows that it retransmit after a timeout and also after a loss ACT. No confirmation ACT, we send the message again. The final one, we ignore duplicate packets. So the way we know that happens is when our sequence numbers are off. So we dropped our acknowledgement, which meant the client was ahead. It was sending the next message when we were trying to get a confirmation. By seeing our sequence numbers are off, we ignore that one. We send a negative acknowledgement to say we're behind, and then we go forward and start collecting from there. So that's how we show we ignore duplicate packets. That is all of 3.0.